My name is Lars Giskehøy. I'm very happy to introduce this talk, this webinar, Python in Unscrambler 11. Unscrambler 11 was released last November, and one of the main new features in that release was the ability to run Python scripts from within Unscrambler itself. So this webinar will be a light introduction to how to use Python from within Unscrambler. It will not go into details about the library that we use for doing that, no technical details about how to actually write the scripts, but rather an introduction to what can be done and where you should get the information you need to get started. I will go through some slides first, point you in the right direction for getting started, and then do a demo in the end. So just give you a very brief introduction to what Unscrambler as a product is and who it's meant for. It's a science-based software. It's developed for domain experts to be able to do explorative analysis using their own data. Right? It's been around since 1984. It has a range of readily available methods for import of generic formats, of proprietary spectral formats, for data alignment, for transformations, plotting, etc. It's also compliant. That means that you can use this software and the model that you build in this software, you can use them in regulated environments under 21 CFR Part 11, EU Annex 11, and those regulatory standards that exist out there. This is an overview of the main methods you will find in Unscrambler. At the bottom, you will see methods that require one data table as input, where the aim is to look for patterns in the data and investigate relationships in one data table. At the top, you will see supervised methods, either for multivariate regression or classification. There are not very many methods, as you see, and that is on purpose, because these methods are, after all, intended for domain experts and good methods. We have some methods for traditional statistics to cover those aspects. We have some for non-linear data, non-linear problems. And then we have the bulk of methods. The mostly used methods in Unscrambler are so-called explorative bilinear methods. So these methods return not only predictions or classifications, but also an interpretation. So it allows you as a domain expert to actually tell why is the model working like this, what is the underlying phenomena being explained. And also it allows you to, or it will flag deviations for you. So if you have outliers in your data or outliers in your process, if you apply this model for real-time use later, then they will be flagged. And that means that it's using these tools, you have basically what you need for most of the situations you might come across. But then in some cases, you might find that you need to import some very special data and some very special format from some old instrument, from some data scheme in the cloud that is not standardized. And that can be a little manual work required. And that means that if you had the script to do it, that would simplify the process. So you can write the script and you can import it directly, time and again, every time you need it. Or it could be that you want to automate some tasks. You don't want to do the mouse clicks every time. And it could also be that you want to try out some different methods. And for this, you can use Python, right? So what is Python? Python is a programming language. It's the most used language in the world for scientific computing. if you have a data scientist in your team, there is a 70% chance that he actually uses Python as his main tool. Python is free. So what does this mean for you? This means that there are actually thousands, literally thousands of scripts available for you to download and use. With Unscrambler, you don't have to know much of Python in order to do this. You just have to fit the readily available scripts into a framework of Unscrambler, and then you can click run and you're ready to go. So what's the advantage of this? One big advantage, of course, is that you can bridge the gap between data scientists and data owners, such as yourself. If you have some tool that you want to use, some new method, it is possible for you to analyze those data with that method by yourself. That means that you don't no longer rely on an external person, a different person, perhaps with less domain knowledge, to analyze the results of your data. It means that you can do interactive analysis using existing tools in Unscrambler, and then you can automate some other tasks using Python scripts. You can tap into big data in the cloud or non-structured data more efficiently by writing these scripts. And you can apply any machine learning method or any different method that you might want to try out or use. It's possible to connect with real-time analytics platform. For instance, we have scripts for connecting to the historian in Process Pulse. And also we have scripts for running models created in Python models created in Unscrambler can also be run using our analytics platform. And it's possible to share these standardized workflows across the organization. Very useful if you have a data science team and also some spectroscopist team or domain experts of different kinds. That means that data scientists can write the scripts and share them, load them. You can load them in Unscrambler and analyze your own data. So everybody can use the same functionality in the organization. So this is all good, you say? So where do I start? What can I do? Where do I find more information? First of all, you need Unscrambler 11, of course. Then, in order to get started, we have a Python resource page on our KMO community. KMO community is free for all to join, and I encourage all of you to join if you haven't done it so already. If you go to community.kmo.com, I will try to do that now. Then you're being taken to the front page here. You log in, go to Resources, Python. And this is the front page for the Python resources. To the left here, you will find all the documentation that you need to get started, whether you are a complete beginner to Python, whether you want to understand how you install Python and load libraries and so on, or whether you're an expert and just want a reference manual to see what sort of functionality is available in our PyKmo library that we use. So how to call a matrix selector, how to create a pandas data frame to use in Unscrambler and so on. In the middle here, we have many example scripts, and I encourage you to use these. And I will show you how just now. I just want to also mention that to the right here, we have added a place where you can actually upload your own scripts and share scripts among yourselves. And There are no scripts there at the moment, but we are hoping that content will be added there moving forward. So this can be a good place for discussions and sharing experiences as well. So now to the examples. So if you go to, for instance, ImportExport, here you will see some examples of very simple script for doing various stuff. So if we look at the import from csv.py, you can see what it looks like here. Obviously, we already have readily available UI-based imports in Unscrambler for CSV files, but I would like to show you this as a generic example still. So what we do is that, as we do in any Python script, is that we declare or import all the packages that we want to use, and then we have some code. Whatever you put in this start method will be run when you click run script from within Unscrambler. This particular example will open a file selector with CSV files. It allows you to select a CSV file, and that CSV file will then be imported into the Unscrambler workspace. So how do I do this? I click download. This zip file will be downloaded onto your computer. You can unzip it and call it directly from within Unscrambler. So what does Unscrambler look like? This is the interface, how it looks when you open it. You have a file menu where you can, for instance, look at the different proprietary imports and generic imports. We have different, here you can connect with Design Expert for doing DOE. We have different plots, different tasks, including several spectroscopic transformations, and different methods, like the one I presented in the slides. When you want to do Python scripting, you go to this Tools menu, Python scripting. So after you first install Unscrambler 11, there will be one script added, which is this one, the test scripts, and the configure entry. These other entries here will be added after you configure and save your own scripts. So the first thing you perhaps will try to do is to run this test script that comes with Unscrambler. What you do is that you specify your Python environment. It's basically a Python exe file. Then you specify the location of this Python script that you want to run. And this specifically is, this script will be shipped with Unscrambler along with some other simple scripts that you can find to get started. Then there is a logging level, whether you want to debug, give regular information, just warnings, or just errors. There are different levels of what to print to the console output. Once you're happy with the script, you can click save, and it will be added here, and it will be added in the shortcut in the menu as well. So when I run this script, it basically prints to the console all your installed packages. It verifies that you're using the correct version of Python, which is 3.7 is what we require. Some older versions of 3 will be supported as well, but not 2. And then it will give you a warning if you haven't installed some important packages, specifically NumPy and Pandas for data matrices in Python. So if you want to configure your own script, like the one I just downloaded, I can click New. I can give it a name called test import CSV. I click the browse button to find the environment, and I go to this file that I just downloaded and add it here. I click save, and it will be added to this list. When I click run script, it goes through everything that is written in this start method that I showed you. So it specifically asked for a CSV file. This is the one I want to import. I click it, and the script completes. So what has happened? Something has been added to this project navigator, and this is the file. So what you typically do then is that you, if you have some category variables, assign them as categories, because that helps Unscrambler to color the plots according to their classes, etc. And also, it's always a good idea to define column ranges. For instance, the spectra does not include the first column, so I can define that here. I can define training and test sets, since that is always important, doing proper validation. Call this these first few samples for training, and the reciprocal collection I can call test. So reserve those for testing. Then I can, very often I want to do some transformation. In this case I can try SNV. I do it on the spectra. I might want to plot the data. So in this case I can plot the training data as a line plot to see the result of the SNV, for instance. And what you see here is basically all the spectra. I can add a legend. I can sample group according to the category that I just created. And this is when the domain knowledge comes into play, because if these are your data, you will definitely know what these different peaks are, right? So these are actually FTIR measurements of different vegetable oils. And then you can go to this region here, because we want to zoom in here. And to this peak around 3014. And using your domain knowledge, you will know that this is actually a peak that distinguishes or that says something about carboxyl stretching. So it's actually able to distinguish between different levels of unsaturatedness in your oils. So what I can do is that I can actually mark those variables, because I think they are important for later. I don't want to do blind pattern matching or correlation searches. I want to do look for patterns where I think that relevant patterns can be found. Also, there are some peaks here which I know are not relevant for distinguishing different vegetable oils, because they describe things like CH stretching, which is common for all. But there is something here in this fingerprint region. You see there is some different areas where it's possible to distinguish between different oils. And this one is interesting here around 960, because this is a peak that says something about whether the oil has been heat treated or not, right? Because it says something about cis-trans isomers. So I'd like to include this fingerprint region as well in my analysis. I mark it, and then I create a range here. And this I can call specific. This is the subset of variables that I want to continue with, right? I can call it, assign it as a spectra in order to influence the default plots in my analysis. So what can I do now? This being a Python webinar, I can, for instance, build different machine learning methods, and I'll show you which script I want to demo now. It's also found in this Python resource page under the machine learning header. It's called ML model build. What it does is that it uses a library called scikit-learn, and it trains several different machine learning methods on these data. Then it does a cross-validation, and it will present a plot with a cross-validation accuracy. So the different abbreviations here are different methods being performed. So since I already set up this configuration, I can basically just click Run Script. I get a model selection dialog select X. So I will select X, the training data only, and the specific column set that I marked. Then I can select the category column. So I go to I select these vegetable columns and also the training data. And then it says, please select a directory for saving the models. So open this dialog here. I created a directory for this already, because what it will do is that it will train these models and save them to file. So now it's actually going through and calculating and cross-validating all these different methods here. And after a short while, the plot will come up with that distinguishes between the classification accuracy of the different methods. And you see most of these performs very well. Some of these performs less well. So I can close this dialog. And I get some warnings because some of these methods require collinear, variables that are not collinear. They might require a certain amount of samples per class and so on. But anyway, they all succeeded in returning something. And then I want to test if this actually performs well on new data. So there is an associated method called msClassify that actually asks for the models to be selected. And here is the trick, because now all the models that are created, these 12 different models, they are saved in the directory I specified under these paths as files on disk. So that means that if I want to apply these models on new data in order to perform classification on the new data, then I can just select these paths, which ones to use. So I can use, for instance, let's select the best ones. Like this, with perfect classification accuracy, and perhaps one which is a bit worse, right? So I click OK. Then I need to select data to classify. I use the test samples this time around. Some variables. And then the script is completed. So what do I have? I have a list of output because that's what I specified the script to return, right? If I want to compare with the ground truth, I can copy that from the data and just insert it here. And now we see how the different models perform, because this is the truth on the left side here. So you see that the first one I selected, I knew, because I validated the models, I knew that this was not as good as the other ones. And we see why here. Some of the samples are classified incorrectly. While most of these methods are actually classified correctly. Olive is easy to classify. Safflower, easy to classify. Corn margarine. So most of these methods perform well, except the first one. But then there is something that we don't really know whether it's a good classification or not, because they are designated other, right? These other samples were not known to the calibration models at the time of training the models. So how can I dig more into these results to understand what are the properties? How can I understand these models better? Of course, I can spend some time and return more output from the Python, or I can use the readily available methods already in Unscrambler to do it. I can show you really quickly a principal component analysis using the same data, training set, specific. I get results straight away. This is a so-called scores plot. I guess most of you know already. You can sample group it. according to the vegetable oils, and you can interpret them in terms of the loadings. So for the first axis here, which is a map of the different training samples, they are associated with high values in this peak here in the loading plot. And this peak is actually associated with unsaturatedness. So you can say that from left to right in the scores plot here, you actually increase the level of unsaturatedness, right? So what about, what's the interpretation of principal component number 2? Then we can look at this peak here, which is actually the peak that describes unsaturatedness. Okay, so this is a reason that corn margarine comes up with high values on this axis, because it contains more trans fatty acids. So you can actually look at this scores plot and say, where would you like to be? Perhaps you would like to have no trans fatty acids. That means that you need to be in this lower area of the plot, and perhaps you like high degree of unsaturatedness, more unsaturated bonds, because that might be healthier. Then you want to be in this region. So what about unknowns? We can use this model and project the new samples onto it, right? So we have the test data. These were not included in the modeling. We click OK, and we get the projected results. So in this case, the blue points are actually the training samples, and the green ones are the unknowns. And we see that these test samples of the olive oils are correctly classified in the same groups. Corn margarine, the same, corn and safflower, all belonging in those areas of the plot where they are expected. And then there were 4 unknowns. They are actually peanut oil, sesame oil, soybean oil, and walnut oil. And this is where the power of these explorative methods are really apparent, because then we understand, we can look at this plot and see that, first of all the unknowns are not heat treated. There are no trans isomers, because they are all in the lower end of the plot. We can also position them and find which level of unsaturatedness they have. And we find that peanut and sesame oils are somewhere between olive and corn, whereas walnut oils is more unsaturated than any of the others. So I hope this was a useful introduction to Python scripting in Unscrambler. So if you want to find out more, you can visit our website at www.camo.com/unscrambler. And not least, you should go and join Camo community just after this webinar. Thank you for listening, and remember to share this webinar to your colleagues later. Thank you.